Welcome students. We're discussing this chapter set and we completed up to types of set, and today we will talk about subset and power set. So before that, some symbols are there. Just learn the meaning of the symbols. First is this symbol is known as proper subset or contained in. That means whenever you're using a subset containing under a set, that time we will use this symbol or for representing the proper subset. This is not a proper subset or not contained in. This symbol means superset. This symbol means subset. This symbol means superset or equal to. Superset of the set, or maybe it is equal to the set. And this is not a superset. This is not a subset. This is not a superset of or equal to. Now we will talk about this symbol in this class, and we will just learn the uses of the symbol. So first topic is the subset. Now what is a subset? If we take this two set A and B, and if every element of A is also an element of B, means all the elements of the set A just belongs to the set B. So that time we will call the set A is a subset of B, and we represent this one A subset sign B. Or this thing we can represent as B is the superset of A and B superset symbol A. Okay, since the meaning is same, their representation is different. Here A is the subset of B and here B is the superset of A. In both the cases, meaning are same. That is, all the elements of A is in B, or all the elements of A belongs to in B. But their representation is different. Here I am saying that A is a subset of B, and here I am saying B is a superset of A. Now let's verify this definition with some example. So first example I am taking A and B, these two sets. A is A, B, C, D, and B is A, D, B, C, H, K. Now I told that A is a subset of B when all the elements of A present in B. So A, first element A present in B, second element is B present in B, the set B, third element is C present in the set B, D also present here. So all the elements of A present in B. So we can say that A is a subset of B or B is a superset of A. Anything you can say. Next, check another example. A is I am taking 1, 3, 5, 7, and X is a set of natural number. So definitely in the set of natural number, this elements 1, 3, 5, 7 contained in this set of natural number. So hence A is a subset of B or B is a superset of A. Next, let A is 1, 3, 5, 7 and X is real number less than equal to 6. So all the real numbers I am taking less than equal to 6. But look at here, the set A contains this element 7. Is 7 belongs to B? 7 is an element in B? No. Since I am taking up to 6, that means 7 is not an element of B. If we can find just only one element of A such that it does not belongs to B, that time we can say A is not a subset of B or B is not a superset of A. Just for only one element. All the elements present in B, but just one element does not belongs to B. That time also we call the set A is not a subset of B. So next, subset of a set. Now what we are doing in previously, where we have these two sets A and B, we need to just check the A is a subset of B or not, or B is a subset of A. So if two sets are given, we can now verify them that is A is a subset of B or B is a subset of A, or A is not a subset of B. But if one set is given, that is, suppose the set A is given and its elements are like A, B, C, then what is the subset of this set? Now look at that. If we consider this set like A, then B, this is also a set. Take one element and make a set. This is also a set. Now take two elements and make pair. AB, BC, AC. Now look at that. All the set A, B, C, AB, BC, AC, and also A, B, C. This all the sets are belongs to this set. All the elements of this set are belongs to this set A. That means we can say that all the sets are the subset of A. So the subset of any set is consists of all possible sets, including its element, including the null set. That means with all the sets, the null set also the subset of any set. Here I am taking another set. A is 1, 2, 3, 4. Then write down its subset. First of all, phi, or you can write just only pair of second brackets, is a subset. Next, just take one element and make a set, that is set 1, 2, 3, and 4. The 4 sets. And now take two elements and then make a set. First 1, 2, 1, 3, 1, 4, then 2, 3, 2, 4, and 3, 4. Now take 3 elements and make a set. 1, 2, 3, 2, 3, 4, 1, 2, 4, 1, 3, 4. And now 1, 2, 3, 4. This element of this set is also present here, and this is what? This is the set A, right? So the set is a subset of itself, and phi is also a subset of any set. So remember this one, that is null set is a subset of every set, and every set is a subset of itself. We can prove it also mathematically that null set is a subset of every set. So let's prove this too. Firstly, null set is a subset of every set. Now, what do you have to show? If a set A is given, they have to show that phi is a subset of A. So if possible, we will prove this theorem or this concept with the help of contradiction. So if possible, this phi is not a subset of A. I just want to check that phi is a subset of A or not. So if possible, take it is not a subset. Now if it is not a subset, that means by the definition of the subset, you can say that in this phi there exists some element X such that it does not belongs to A. So we have some element in phi such that it does not belongs to. That time we can say that this phi is not a subset of A. Otherwise we can't say that. So if phi is not a subset, so take this symbol means there exists at least one element X in phi such that X does not belongs to A. Now if X does not belongs to A and X in phi, but phi is what? Phi is a null set. So if null set has no element, then we can't find any X that belongs to the phi, right? So this is your contradiction. So if this is your contradiction, then you can say that our assumption is wrong. That means phi is not a subset. This assumption is wrong. So we can say that phi is a subset of A. Okay, hence the phi is a subset of A. So the next one, every set is a subset of its own. That means if a set is given A, then we have to show that A is a subset of A. In a similar manner, just check if possible A is not a subset of A. So by the definition, you will find some X in A such that this X does not belong to an A. But is this possible? X, here I am taking X is present in A or X is belongs to an A, but X does not belongs to A. This is a contradiction because it is not possible. First time I am taking X is in A and then I am taking X does not belongs to an A, which is a contradiction. So if we conclude a contradiction, that we can say that our assumption is wrong. That is, A is a subset of A. So every set is a subset of its own. So the next one is proper and improper subset. So now we can write down all the subsets of a set. Now we know how to write down all the subset of a set. So among this all the subset, the set itself and the phi is known as the improper subset. So if we take a set S, then S and phi is the improper subset of the set S. And except them, all the subsets are called proper subset. Okay, so let's take one example. A is 2, 4, 6, 8. Then A and phi is the improper subset. And write down the proper subset. That is 2, 4, 6, 8, 2, 4, 2, 6, 2, 8, 4, 6, 4, 8, 6, 8. 2, 4, 6, 2, 4, 8, 2, 6, 8, 4, 6, 8. So these are the proper subsets of S, and A and phi is the improper subset. I think this concept of proper and improper subset is clear. So moving to the next one is power set. What is power set? So all the collection of the subset of a set is called a power set. That means if we make a set with all the subsets of a set, that time we called this total set is a power set. So power set is represented by P of the set. If you take the set as A, then P of A is the power set. P within the first bracket A. So take any example. Let's check the power sets. A is A, B, C. These three elements present in the set A. So write down its subset. You know that phi A, B, AB, AC, BC and ABC. That means the set itself. So these are the subset. Now all the collection of this subset is the power set. That means if we make a set with all the subset of it, we'll find the power set. That means all the element of the power set is again a set. Look at that. This is one of the set. This is a set. This is a set. So all the elements of the power set is a set. Okay. Next example, take 0, 1, 2. So the subset are 0, 1, 2, 0, 1, 0, 2, 1, 2, 0, 1, 2. That means itself. Then the collection of then the power set is collection of all the subsets. So write down all the subset within the second bracket. This is your power set. So I hope this power set concept of this power set is clear. So the next, solve some problems from the exercise 1.3 from your NCERT book. Write down all the subset of the following sets. First set is given singleton set. So singleton set means the subset are only phi and itself. Except this two, it has no subset. Now two elements A and B. So the subsets are phi, AB, A and B. These four sets. Now for one element, you are finding two subset. For two elements, you are finding four subset. Now for three elements, 1, 2, 3. Let's check the number of subsets. So phi 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3. So that means 1, 2, 3, 4, 5, 6, 7, 8. Total number of subset is 8. Here the number is 4 and here the number is 2. So can we write this thing as 2 to the power 1? Since one element, this is 2 to the power 2, that is for 2 elements, and this is 2 to the power 3 for 3 elements. So let's check the next one. How many elements of a power set P of A if A is 5? How many elements has this power set when we consider the set is 5? That means it has only one subset, that is only 5 itself, or you can say the null set, both are same here. So the number of subset of this A is just 1. Now look at that. 1, I can write down this one as 2 to the power 0, right? Since there is no element, so the number of element in the power set is 1. So we can write 1 as 2 to the power 0. So look at that. For no element, we are finding the number of subset is 2 to the power 0. Or you can say the number of element in the power set. The number of element in the power set actually is 2 to the power 0. Now if the number of element in the set A is 1, so the number of element in the power set is 2, that is 2 to the power 1. Now number of element in the set A is 2. That time number of power set we already calculated in our previous example, that is 4, that is 2 square. If the number of element in the set is 3, so number of element in the power set is 2 cube, that is 8. So from here you can say that A is a finite set and the number of element in A is n, then the number of element in the power set of A is given by 2 to the power n, right? You can prove this number of element of the power set is 2 to the power n by the process mathematical induction. You can prove it too. Now all the example exercise problems from exercise 1.3 are very easy and they are just short type question, one word question. So solve these problems. I think they are very easy. You can solve it. If any problem or any doubt is there, you're free to ask. Thank you.